welcome to my living room. I'm glad there's enough seating for everyone. I'm making tea, but it's going to take time, so we'll get there. I am going to talk this morning about some more grandiose themes, but actually in another sense, it's going to be more fine-grained because we're going to move a layer down from code and look at the actual architecture of the internet. Because we're in a really amazing time right now. The fundamental architecture of the internet is changing in ways that it hasn't in many, many years. In fact, you could easily say that the web is changing more now than it has since its creation. So we're going to look at some of these trends. At Akamai, we have a lot of insight into that because of the platform we run. So let me set the stage with that, in case you don't know Akamai already. So we deliver every day somewhere between 15 to 30% of all the traffic on the web. It's a big amount. We have to make sure we do that right. Now that represents about 30 terabits per second. I'm a technical guy, but it's hard to think what 30 terabits a second is. That's about 40 million hits every second against our platform from end users all over the world making requests for different types of content. Now, we do that based on our massively distributed platform. It's the only way to really effectively serve traffic at that scale. So we have 200,000 servers that are located in over 110 different countries and 1,400 different networks. The big numbers are kind of impressive, but really the important one is the 1,400 networks. The way that you can actually get content delivered really efficiently and effectively with good performance to end users is by serving it to them from their own ISP, their own network. So that's why we try to be in so many of them. So this gives us a lot of insight already. You can see it's a lot of the traffic on the internet, and then the types of customers on the platform. I won't go through all of these, but most of the major e-commerce sites on the internet, the top 30 media and entertainment companies, 9 of the top 10 social media, newspapers, large banks, software companies and security companies, and in the end, 1 out of 3 of the Global 500 is on the platform. So you use this every day, whether you're aware of it or not. So I'm going to use the data and the insight that we have to show you some of these trends and what's coming. But before I actually dive in, let me tell you that we have this available online. We publish every quarter a State of the Internet report, and it includes lots of trends on what things are changing, what's happening, and what's going where. It's available at www.stateoftheinternet.com. And actually, you can find a sort of PDF report version of these trends, but there is additionally an interactive web application that you can use that will let you compare different types of data from different countries. And there's also a mobile application. So if you search for Akamai, we lost the audio. Are we okay? All right. Now you're awake. I have your attention for 5 minutes, and I don't know what to say. All right, mobile application, AkamaiStateOfTheInternet.com. It won't make things fall down and break when you try it. Give it a shot. It shows you lots of these data and statistics. So now let's see what we can actually get from that data. So we identify from it a number of key trends, and I'm going to go through 4 in this talk today. The first one is around mobile, the adoption of mobile, but how that really isn't integrated into the architecture in an effective way and what's happening because of that. The next one is video, the increasing consumption of video online. It seems like we're doing a lot more than we used to, but there's a lot more to come, and there's going to be big challenges associated with that. Security, this we all see every day. The threats are getting, the vulnerabilities and attacks worse all the time, which seems like it's going in the wrong direction. So how do we address that? And then finally, some very interesting trends in enterprise networking. Okay. Now, these are trends that we identify. Actually, there's hundreds of trends. We could talk about adoption of IPv6. That's in the report. But the reason I've chosen these 4 is because they're the ones that also represent major challenges for the future of the internet at a technological level. And so we're going to need to see fundamental change to address them. So let's start with mobile. One paradox here is that even though everything is getting better and better, we've got faster devices, faster mobile networks, faster fixed-line networks, the web is actually getting slower. That's a totally strange phenomenon, right? But you can start to see some of the reasons here. The average web page now takes longer to load than it did 2 years ago, and much longer than it did 4 or 5 years ago. And it's because we're producing heavier pages. That's one of the components. So, for example, the base page itself is now lots more data. Well over a megabit just to get the HTML down to the device. On top of that, there's a lot more JavaScript. That first talk this morning on JavaScript coding was great, and you see all the things that are coming, but remember, you have to deliver all that JavaScript with the site, and that has an impact. Images is a huge one. Not only are websites filled with rich images, almost the entire website is images now, but they're much higher quality than before. Why? Retina displays drive a lot of that, so lots and lots of big images, there's more CSS, there's a lot more third-party content as well, and that has an impact on the page performance. And then, of course, the big one that I haven't mentioned is the growth in mobile. Right? So this is data that's gathered by Ericsson, and it's showing the growth in voice data versus mobile data on the mobile networks. And blue is voice and orange is mobile. I guess voice is growing, but you have to look real hard. The data part is exploding. Right? We all know this intuitively, that there's a shift to using the web from mobile, but this shows you how much, and that this isn't slowing down. That's 2009 until Q2 this year, just these past few months. So the problem with this is that the web was not really at all well architected to work on mobile. We had the web architecture, and then we had mobile, and we just stuck them together, and we said, that'll work well enough, maybe, but it doesn't. And so as a code stage, I hope everyone here is a little familiar with this type of diagram. It's called a waterfall chart. And it's showing behind the scenes what happens when you load a single web page. You remember, of course, you request the first base page, that HTTP request, but then you have to make additional GET requests for every single included object. Every piece of JavaScript, every picture that's included, other third-party content that's included, and these bars are showing all of those behind-the-scenes requests that the browser makes. Get me this, get me this, get me this. Of course, the trouble is a real web page looks like this. We now have hundreds, easily hundreds of objects on a page, and this is a typical site. This is not fancy. So this has a real impact on how the device is interacting with the network and how we've architected these protocols. So let's look at an example. So this is me, actually. I typed at my computer to just download the web page for our corporate website. And you can see highlighted in red here, these are the HTTP headers. Right? Remember, each of those GET requests, you have to send back a bunch of extra information about the HTTP request. And sometimes this can be quite large. If you got cookies, every cookie you ever got from that site, you need to send on every single GET request. And the way HTTP 1 was architected, that can't be compressed. You have to send it every time, all of the data for each of those 100 requests. On a mobile network, this kills performance. This is terrible, right? Now, this is one example of many, but it's this type of thing that led Google to create Speedy, which then led to, was the inspiration for and the driver behind HTTP 2. It resolves this type of problem and some others. So that's already the beginning of this fundamental shift. You can see HTTP 2, that's the first change in HTTP, the core protocol of the web, in 15 years, and basically since its creation. You've seen how the actual web has changed in 15 years, but we didn't bring the technology along to the same level. Now, what's good about this is that we're in an improved state now. HTTP 2 will take off and solve a lot of these problems. But in reality, HTTP 2 was just catching up on the 15 years of stuff we should have been doing before. We got consensus on it pretty quickly. It was, tricky, but not really, really hard. But what we're doing now is looking at what's going to come next. Now, this performance stuff, I always take a small minute to just say, why does performance actually matter? It seems like, okay, a little faster, a little slower, what's the big deal? The truth is, it's now well studied that even small changes in performance can have a really significant impact on the experience that users have and on their behavior. So this is talking about, they get a slower website, well, they'll switch to someone else's site or app, or they're less likely to make a purchase or have negative brand perception. But my favorite studies along these lines, this is one we did in conjunction with Walmart, but you can also find similar studies from Google and from Amazon, which is that if you add just milliseconds of delay, 100 milliseconds, 200 milliseconds, people change their behavior dramatically. This is showing so from the left to the right here, on the left, in the blue is the percentage of users that received the page in 0 to 1 seconds. And then to the right, it's the users that received it in 2 to 3, 3 to 4, and all the way to the right, you can see there's a large percentage that took over 11 seconds to load the page. probably a significant portion of those are mobile users. Now, what's really truly interesting is the orange line. That's the conversion rate, the percentage that actually made a purchase. And you can see at the left, really great performance, most likely to make a purchase. But look how quickly it drops off if you add just a second of delay. All of a sudden, people aren't using your site the same way anymore. They don't want to engage. So performance matters. But what's interesting is to see where is this going to go now. We have HTTP2. That's the first kind of canary in the coal mine that's going to show you a lot of other things are coming. But now we're going to see work on UDP-based HTTP protocols. That's in progress right now in the standards bodies. And then there's going to be much tighter integration of technology between the networks and the content. If the content can be aware of the network and the network aware of the content, we can do much, much better than what we did today, which was just stick a couple of technologies together. So that's on the mobile side of things. Let's switch to video. Now, video is a funny one because we all feel like, hey, we finally really have video online. Although every year we kind of say, there's going to be a lot more. Are we there yet? Are we not there yet? So this is representing some events that we deliver on our platform. It's the FIFA World Cup in 2010, then the 2012 Summer Olympics, the 2014 Sochi Winter Olympics, and finally to the right was the FIFA World Cup in Brazil last year. So you can see immediately these are very spiky events, lots of traffic. We're talking over terabits, 7 terabits a second for a single game. But let's look at it in a little more clear fashion here. This is the relative event size in terms of bytes delivered. So on the far left, 2010 World Cup. On the far right, 2014 World Cup. 4 years, the event was 8 times larger, right? This is an explosion. Now, there's more than one reason for that. Part of it is that more people are watching video online today than used to. There's an increase in adoption. And then at the same time, the bit rates are much higher. Right? Now we're actually watching in high definition, and there's an expectation of high definition, and people are paying for high definition video quality on the internet. Of course, the internet really has trouble keeping up with that by itself, but that's the world that we're in now. But now let's look where we're going. So this is events, large peak events delivered from our platform from 2000 up until 2014, last year. That 26 terabits per second, that was the peak for 2014, a large amount of traffic. You can see the growth that's exponential from the years before. But let's do a little math to see where we might end up. 26 terabits per second is a lot, but we know how to serve it. So let's imagine we have 2.5 billion primetime viewers, right? They're going to watch some type of live event on the internet. And let's say they're going to watch it at 10 megabits per second. This is a reasonable thing for the midterm future. It's better than DVD, but not 4K, right? So we do that math, and we get 25,000 terabits per second that we have to deliver online. On this graph, that's where we are. It breaks the internet. It's not an exaggeration, right? How do we imagine serving 25,000 terabits per second? Well, the truth is, even though we've done all this work to be highly distributed and use these special algorithms that's very, very scalable, it doesn't scale to this, and we're going to need new technologies. Now, what are these technologies? There's actually a number of them that are likely to come to play to be able to serve that video of the future. One of them is hybrid HTTP-UDP delivery. You may remember that we all started with UDP-based streaming for video on the internet, and then UDP had some problems, and so the world switched largely to HTTP-based video delivery, and that solved a lot of those problems, but we also lost some of the benefits of UDP. So now there's an opportunity for a combination of the two. Let's use HTTP for control, UDP for delivery of the actual bulk content, has very nice properties for aspects of video delivery. So that's one thing we can do to get there. Another is multicast. Boy, I hate calling multicast a new technology. For those of you that have been around a while, it's over 20 years old. Right? This is not a new technology, but it's never really gotten adopted. There's a number of reasons for it, partly because we've always managed to find a way to stay just out enough ahead to be okay, and it wasn't really critical. But for that 25,000 terabits a second, we're going to need stuff like this. If you're not familiar with multicast, today, say you're in an office building and you're watching a video sporting event online, and so are 10 of your friends, you're all getting your own copy of the data. It's 10 times the data. With multicast, you can send one copy of the data. Anyone who wants to watch just taps into it and receives it. So it's much more efficient on the network, and because it's more efficient, you can serve the video at a much higher bit rate and higher quality. So multicast will be important. There's a lot that can be done with intelligent pre-positioning. A lot of the time, it's very clear which video is going to be watched far before it's actually requested. So let's get it there ahead of time and support the network that way. And then peer assisted delivery. This is clearly also a component of how to get to the end version. Now, the tricky thing about all this is how do you bring it together? Is one going to win? Is another going to win? The reality is, where we are today, there's intelligence. We started at the core, and now that's expanded out to the edge. That's where the delivery is done from. But in order to get to a place where we can reach both the efficiency and a technological position to understand how to use them, we need to go even further. Today, we're also, to some extent, in devices on the mobile device or in the computer, but it also needs to extend into the home. That way you can make intelligent decisions. I'm watching something live right now. I'm going to use the multicast stream, but I use the DVR function to go back 5 minutes. I better switch over intelligently to unicast and make that work effectively. So there's a theme across the technologies, more intelligence, deeper into the edge, into the devices. Okay, we'll shift gears to security. Now for these first two, for mobile and for media, it's important to set the stage some because it's hard to have a sense for what's going on. Security, I don't have to set the stage. This you can just open the newspaper. We all see this every day. There's always another bigger attack, data that's being stolen, large online denial of service attacks, and it seems to be getting much worse over time. Now the anecdotal story is clear, but we can also look at some data. So first, the DDoS attacks are getting larger, and they're getting more frequent. We measure, these are attacks, major attacks against customers on our platform. So there's a lot of attacks that we can just sort of not even pay attention to. We don't even know they're happening. We just brush them off. But these are ones that were a major significant attack. 2009, 14 attacks, major attacks on customers on our platform. So that's one a month or so. And I remember when these occurred, it was kind of an interesting event. Oh, some customers being attacked. It's interesting. Let's look at that. But you can see 2014, 1,274 attacks, right? That's more than one a day by far, right? It's more than two a day. So it's not an event anymore. The attacks are just the normal state of business. So this is getting to be a difficult situation with more frequent attacks, but they're also getting larger in size. So our record-setting attack last year was 320 gigabits per second. These attacks are getting both larger in volume, but at the same time easier to execute because there's a kind of commoditization going on now. There's sites that will just let you, sign up, and they say that it's to stress test another site, your site that you're maintaining, but really it's to attack another site. So this is a difficult landscape. Now, this is just showing that record-setting attack last year, 320 gigabits per second, and it's not just one type of traffic that hits you all at once. It's lots of different attacks combined. It's more sophisticated now, and they're able to do a lot of things to try and manipulate the situation. So for the volume attacks, you need to have a big distributed defense. You need to keep the attacks at bay, far from where the origin and core infrastructure is. But last year, there was the phenomenon of some really precedent-setting security vulnerabilities on the internet. It was sort of an eye-opening year, 2014. I think everyone in this room probably is aware of shell shock, right? This was a bug in Bash that made web servers vulnerable to attack. Bash is so old, and the bug itself was like 20 years old, but only now are we realizing that we combined some technologies, a shell scripting language with a web server on top, in a way that could have a vulnerability like this. And by the way, once that vulnerability was announced, it was just days before there were hundreds of thousands of different types of exploits trying to take advantage of it. Okay, well, we had the Bash bug. That was crazy. But then there was Heartbleed. Remember Heartbleed? So this was the bug in OpenSSL that would let an attacker get the private SSL cert out from the server. That's a disaster for security, right? That would let you impersonate some other big website. I could pretend to be your bank and ask for your login details and do something with your online banking. Now, Heartbleed was a big kind of crazy event. The software got patched, and you could look at this as just a bug. It was just a bug, right? It's not a fundamental problem. Except, here's what happened next. People saw the bug, they patched, and then once they were patched, the first thing they did was rotate their certificate, right? Which is a good thing to do. It's good to rotate the cert, so you're not using that private one anymore. But if someone actually had stolen that private key, the only thing that's really going to protect them from someone else impersonating their site is to issue a revocation, right? So you need to issue a cert revocation, and now we have thousands, hundreds of thousands of compromised sites potentially that need to issue revocations. The system doesn't actually work for that. We didn't build the right architecture. Can you imagine if your mobile device had to download, megabytes and megabytes of revocation data just to make each request? We didn't build something right there. And so that's leading now to a fundamental re-examination of some of the security protocols that define the internet. And some of the largest players in the industry are participating in this now to say, what should we be doing next? There's some sort of short-term versions of things that are being pushed to at least add transparency. If some rogue CA somewhere signs a cert for your site, at least could you get notification? That's one thing that's in the works. But there's lots of possibilities here. It's conceivable we'll end up in a future where we don't have CAs, where we don't have certificate authorities for web security. Maybe we're going to end up somewhere else. The talks are happening now. There's a lot of real change going on. By the way, there's also intermediate versions of that, right? We could have just certs that are signed more frequently, not for a year, but this is what's going on now. So it's an interesting time on the internet. So let me turn last to enterprise networking. This one might be a little bit less obvious what's going on here. So we started to identify with some of our customers, especially the retail ones, that the needs that they had in branch private network environments were not keeping up with the technology available. In particular, you can imagine there's a large luxury retailer with thousands of storefronts around the planet, and they had an iPad application that they wanted to use to interact with their customers. The sales associates would, show the version of the we just lost the slides there. Okay, but they would show the watch that they wanted to buy and how it would be customized and everything else. So the difficulty they had was they didn't have good enough performance on that network connection. All the stores had a private network connection back to the data center. It wasn't keeping up with the needs. There's more and more web applications, but the capacity wasn't there. And it's so expensive to upgrade that on thousands of stores around the world that it wasn't really a viable option. So making that a more performant environment is one step. But of course, there's also the problem that companies are using more and more third-party cloud applications from the branch. So that goes back to the central data center and then out to the cloud, and that's not very efficient. It'd be better to go direct to the internet. And that's what we're seeing more and more. There's direct internet breakout, but when you have that direct internet breakout, you've removed some of the things you liked about those private networks. In particular, there's certain performance and reliability expectations that you can have in a strong way. So there's another piece here where we see a trend for an intermediate technology that's able to have, and this is the true hybrid WAN, an internet that is more reliable, a service on top of the internet that can have less packet loss, less latency. It's still the normal internet, but it's more cost-effective than the private line, and not quite at the same performance, but a better performance than internet level. So that's hybrid WAN, and that's one of these trends that it's starting to happen now, and it's going to become big. So, all right, we've got slides, but not the clicker. Okay, so these are the four main trends. Mobile, video, security, and enterprise networking. It's interesting to see everything that's happened so far. There's so many fundamental changes going on right now, but really this is just the beginning. It's very easy to believe that we've all come into this web thing and the internet thing after the crazy days where it all got created. The problem is it's always easy to think that you're coming in late. But the truth is, right now is this major pivotal time where a lot of the early stuff is being rethought, redesigned, and re-architected for the next 5, 10, 20 years, because it's going to be a very different world that we'll end up in the near future. Thank you.